Hey everyone, welcome back. This is Aksharuba. So in my last video we have discussed about the mesh method, and in today's video we'll be discussing more about mesh method, different kinds of problems we can do in mesh method. Now before doing these problems we need to know something very important which is required to solve this problem. So current source to voltage source and voltage source to current source. First let's begin with current source to voltage source. Here I have a simple circuit and we have a current source, two parallel resistance R1 and R2. In current source to voltage source, the most important part is that the current source should be connected to a parallel resistance. Only then this can be converted to a voltage source. So in this circuit we have a current source that's parallel to a resistance. That's a resistance R1 that's parallel to the current source. Let's begin with it. Here I have a framework of the circuit the voltage source circuit. So to begin with, here we have a current source I1 and the direction of current is upward. You can see here there's an arrow marked upward. So the direction of current is upward. So here the direction of current should be upward, which means according to conventional current the positive should be here. So this is a voltage source, positive, that side. So the direction of current will be the same, will be upward. Next is, so we'll mark it V. And then the resistance that's parallel to the current source, it's going to be series with the voltage source. It's going to be here, R1. And the other resistance are going to be same. Here we have two resistance, only for if there are more than 2 volts, it's going to be the same. That's why I said it's very important that the current source has a resistance that's parallel to it, so that when you convert it to a voltage source, it can be in series. So this is how it's done. And to find the voltage, we have to find the voltage here, the voltage of the voltage source. We already know that V is equal to IR. So that's what we're going to do here. V is equal to I into R1. So it's this one, R1. It will be the value of R1. So to convert our current source to voltage source, you need a current source that's connected to a parallel resistance, and when you convert it to a voltage source, the resistance becomes series with the voltage source, and the voltage in the voltage source will be V is equal to I into R1. Next, let's do from voltage source to current source. I have a simple circuit to convert voltage source to current source. Pardon. So in the voltage source we have a series resistance R1. The voltage source is connected to a series resistance R1, and there's R2 and R3 which is connected in parallel. And let's convert it. Here I have a framework of the circuit, the current source circuit. Let's begin. Here you can see that voltage source, according to conventional current, the flow of current will be in this direction from positive to negative. So here is the positive of the voltage source, will be in this direction. So let's draw a current source, and the direction of current will be upwards as it is in here. And mark it I. Next is the R1. In the current source, we saw that the parallel R1 is connected in series when it comes to the voltage source. In voltage source to current source, the series R1 will be connected in parallel when it comes to current source. So the R1 here will be connected in parallel here. And the other resistance are the same. If they are connected in series, they will be connected in series. Here, since they're in parallel, you continue connecting it. So R2, R3. So that's how you do it. We should find the I current value. So if you know the voltage value, it's easy to find the current value like we use here. V is equal to I into R. You just rearrange the formula. I is equal to V by R1. Yes. So this is the basic to do the mesh problem, the mesh question that we are going to do today. Let's move on to the problem. We have the question here. It's a simple circuit, but the specialty of this question is that there is a current source and there's a voltage source. So normally in my mesh method part 1 video you must have seen, we have two voltage source and then we find the current in all the branches. But here we have a current source and a voltage source. So let's see how to do this. To begin with, first we need to convert this current source to a voltage source. So as we have already discussed, to convert a current source to voltage source, it should have a parallel resistance connected to it, and we have a parallel resistance here. It's a 10 ohm resistor. So let's do it. Let's convert this circuit with voltage source. Here I have the framework of the circuit with the voltage source. So as we already know, there's a current source that's facing this way, the arrow is facing upwards, in the sense the current is flowing upwards. So we put the positive side of the voltage source there. Yes. Now next, if you see, there is a parallel resistance here. When you convert it to a voltage source, the resistance will be connected series with the voltage source. So let's do it. 10 ohms. And then there is a resistor that's parallel here, so we put the resistor parallel there. There is a resistor, 5 ohm resistor there. And there is a 20 volt voltage source, so 20 volt. I've missed here, I made it's ohms, 5 ohms, sorry, 5 ohms. So you can see we have converted the current source to voltage source by taking this 10 ohm resistor that's in parallel with the current source and made it series with the voltage source. Now we need to find the voltage of the voltage source. So we have already discussed V is equal to I into R1. So here V is equal to I was 1 into R1 is 10 ohm. This resistor is R1, R2, R3. So R1 is 10 ohm. So you give 10. So V is equal to 10 volt. So this is 10 volt. Now we have all the values. If you look at the circuit, you might feel that you have seen the circuit somewhere before, because in my last video, that's mesh method part 1, we have done this problem using the circuit. So if you haven't seen that video, please go watch mesh method part 1 first to understand this problem better. So it's the same problem. Now let's solve this in a bit different way. So first step we already know, you need to identify the mesh. So first let me label it A, B, C, D, E, F. Now we know the mesh here, A, B, C, D, A, and then C, D, E, F, C. There are two mesh. So let's write. In my last video, I've explained in detail how to solve this. Please watch the video so that you will be able to understand this better. Next step is marking the mesh current. So here last time we did both one sorry, clockwise and the other anti-clockwise, clockwise and anti-clockwise. This time let's do both clockwise. So I1 clockwise, I2 clockwise. Since we did both, one clockwise and other anti-clockwise last time, you might have a confusion how it will be done when it's clockwise and clockwise or anti-clockwise and anti-clockwise. So we'll be doing that in this video. Next step is marking the current in each of the branches. So to begin with BC, in BC I1 is passing and it goes like this. It goes like this. So it goes from B to C, I1. Next is CF. In CF, I2 goes like this. So clockwise, so it goes from C to F, mark it I2. Next is C to D. In C to D, there are two currents that's passing. First one is I1 that's passing downwards. It goes like this, so I1 passing downwards. Next is I2 that's passing upwards. If you see, it's passing upwards. It goes like this and it goes upwards. So I2 is going upwards. Now you'll have a confusion. How do you, which current do you take that's passing? What's the direction of current? So here you can take one of the current to be larger, either I1 or I2. The larger current will flow, the current will flow in the direction of the larger current. You will know that. So I'm taking I1 to be larger and I'm marking the current to be going downwards, and I1 is larger, so I1 minus I2. This is I1 minus I2. I repeat C to D. In C to D, there are two currents that's passing. One is I1 that's passing downwards, and another one is I2 that's passing upwards. So we consider one of the current to be bigger. You can choose, it can be I2 or I1. I choose I1 to be bigger, so I mark the current direction downwards. That's I1's current direction, and I1 minus I2 will be the current passing through this C to D. Now let's move to the next step. That's you need to identify voltage rise and voltage drop. So in the last class we did it using the table. Here we can just directly write down the equation, because when you practice with a table for a lot of time, then you will get used to doing it with equation directly and it'll be much easier. So V rise equal to V drop according to Kirchhoff's voltage law. And here let's begin with A, B, C, D, E, A. That's mesh 1. So we begin with mesh 1. First A, B. So A to B, there's a voltage source and it's moving from negative to positive. If it is moving from negative to positive, as you all know it is V rise, it's voltage rise. So we give here 10. Next, we've moved from B to C. B to C is we're moving along with the current I1. If you're moving along with the current I1, then we all know what it is. That is voltage drop. So, the voltage drop side, I'm going to write, the voltage will be 10 into I1 because B is equal to I into R. So, it will be 10 I1. Next, we'll do C to D. C to D. So in C to D, the current is passing downwards. So we are moving along with the current. We are moving along with the direction of current, and that's again voltage drop. So in voltage drop, we'll be writing the 6 ohm resistor. So 6 into I1 minus I2. The current that's flowing here is I1 minus I2. So we write 6 to I1, and then there's nothing. So this will be our equation 1, the first equation. When you simplify the equation, this is what you get. 16I1 minus 6I2 equal to 10. So that's our equation number 1, which we got from our first mesh A, B, C, D, A. Now let's move on to the second mesh. So C, D, E, F, C, the second mesh. And again, we rise equal to we drop. So let's look up the circuit first to C to D. So in the circuit C to D is current I1 minus I2 is flowing, and it's moving in our direction. We are moving along with the current, so directly we can write it in V drop 6I1 minus I2. Next is D to E, D to E. There's nothing in D to E. Let's move on to E to F, E to F. So in E to F, if you see, we are moving from negative to positive of the voltage source, negative to positive. So negative to positive is voltage rise. We already know that. So in voltage rise, we can do 20. And next is F to C. F to C, we are moving against the current I2, that's flowing in here. So against the current is voltage rise. So here we write plus that 5 ohms, so plus 5I2. Here we got our second equation, and when you simplify, 6I1 minus 11I2 equal to 20. So we have an equation 1 here and equation 2 here. We can use our calculator to solve these two equations and find the I value. So I have my calculator here. Now it's in the normal mode, so I'm changing the mode. Simultaneous equation, number of unknowns is 2. So let's type in the first equation, that 16 equal to minus 6 equal to 10, and the second equation is 6 equal to minus 11 equal to 20. So 20 equal to the first values minus 0.07, b minus 0.07. Next value is minus 1.86. So these are the values of I1 and I2. Since you know the value of I1 and I2, you can easily find the branch current. Here it's I1, here I1 minus I2, here it's I2. So you can easily identify the branch current. And this is how you do it. I hope you must have understood how to solve this problem using a current source. We first converted the current source to a voltage source, then we used the mesh method to solve the problem. Current source to voltage source to current source. Thank you for watching this video. If you haven't liked and subscribed to my channel, please like and subscribe to my channel. If you want if you want to clear any doubts, please comment in the comment section. You can write any topics which you want me to explain in the next video. I will do that. And if you have any doubt, you can comment. If there's any point you have to clear also, you can comment. I will explain that in my next video. We have an mesh method part 3 coming up next. It will be with the current source and voltage source. So this part is really important. Thank you for watching. Bye bye. See you all in my next video. Ta-ta.